By the end of this lesson, you will be able to answer grade 8 questions like the one here on the board using either tree diagrams or just by using their probabilities. So stay tuned. Right, so on to our next question. Now this is quite a mouthful and it's quite meaty perhaps, so pay attention. This is probably, you're looking at a grade 8 on your GCSE. Each day Musa wears a black tie or red tie to work. On Monday, the probability that he wears a black tie is 0.6. If Musa wears a black tie on Monday, the probability that he wears a black tie on Tuesday is 0.35. If he doesn't wear a black tie on Monday, then the probability that he wears a black tie on Tuesday is 0.68. Complete the probability tree diagram. Right, so that's our first reading of it. Let's now go through the question, highlight some relevant parts and refer to the probability tree diagram. All right, so each day Musa wears a black tie or a red tie. So we have two different choices for ties. We can either have a black tie or a red tie. And this is where you'll notice on the tree diagram, we only have black tie and red tie. On Monday, the probability that he wears a black tie is 0.6. So this is our two outcomes for Monday. So the probability that he wears a black tie on a Monday, is 0.6. So we can actually put that in here. So what do we know about probability tree branches? We know that they have to add up to 1. So when we knew that the probability of a black tie on a Monday is 0.6, what do you think the probability for a red tie would be on a Monday? Hopefully, you're sitting there thinking 0.4 because that would be correct. So let's continue with the question. If Musa wears a black tie on Monday, the probability that he wears a black tie on a Tuesday is 0.35. So if he wears a black tie on a Monday, the probability on Tuesday that he wears a black tie is 0.35. And let's write that in here. There we go. And from here, we can also find out the probability for a red tie on a Tuesday, which would be this to add up to 1. So what is that going to be? That's going to be 0.65. So the probability of a red tie on a Tuesday is going to be 0.65. Back to the question. If he doesn't wear black on Monday, which means that he's wearing red on a Monday. If he doesn't wear black on Monday, then the probability that he wears black on Tuesday is 0.68. So this is if he doesn't wear black on the Monday. So, which means he's wearing red on the Monday, and therefore the probability that he will wear black on the Tuesday is 0.68. And once again, with these branches adding up to 1, we can know this probability, which is that he wears red on a Tuesday, and it's going to be 1 minus that, which is 0.32. So there we have it, a fully completed probability tree diagram, which was quite meaty, it was quite mouthful. And you saw how I went through every single sentence, tried to understand it, and tried to put down the information into the tree diagram as I was going through it. And then we found that it was like a jigsaw. Once you got one piece correct, then you start to realize, this goes there or that goes there. Okay. Now let's look at a question for this type of probability tree diagram. So let's have a look at the question we are going to answer for this tree diagram, which is work out the probability that Musa wears different colored ties on Monday and Tuesday. So what are we looking for? We are looking for two different colors on our tree diagram. So for example, if on Monday he wears a black tie, then on Tuesday it has to be a red tie. So let's write this down. So it's going to be black on Monday and on Tuesday, and we can use and, or we can use the symbol which is intersection. So blue and red. Okay, that means and. So that's one combination. But if he wears a red on a Monday, then he has to wear a black on the Tuesday. So we need red and black. That's going to be or probability of red and black. And there are no other combinations where you have two different color ties. You only have black and red and red. Now let's find these probabilities from our tree diagram. So what is the probability of black and red? The probability of a black on a Monday and the probability of a red on a Tuesday, which is from our diagram, this is 0.6 and means times. So 0.6 times by 0.65. And or means to add. So we want a red on a Monday and a black on a Tuesday. So red on a Monday and a black on a Tuesday. So it's going to be 0.4 times by 0.68. Now I'm just going to put this into my calculator, but I've done the answers earlier on, so they are 0.39. So from the calculator, we've got the answer 0.39 plus 0.272, and we can add them together, and when we've added them together, we get 0.662. So our answer for the different colored ties on Monday and Tuesday is 0.662. Now on to our next question. We have another grade 8 question here. We have 10 counters in a bag. We have 5 red, 3 blue, and 2 green counters. Jatinder takes 2 counters at random, without replacing them, of course. Find the probability that both counters are the same color. Now, this question, we can actually avoid using probability tree diagrams, simply because it can get quite crowded because you have 3 different options. So just to give you an idea, you're going to have this on your first branch, and you're going to have this on the second set of branches. So as you can see, it can get quite congested. I want to show you how to also answer some of the probability questions where you don't necessarily need to do the probability tree diagram, as long as you understand what's going on. But of course, if you can't visualize what's going on, then the tree diagram helps you trace the patterns and the roots, okay? So here we go. So the first thing we want to do is write down our probabilities. So we have the probability of red here, which is going to be, so let's write this down, probability of red, or probability of R if you like, is going to be 5 out of the total number of counters, which is 10. So 5 out of 10. And the probability of blue is going to be 3 out of 10. And the probability of green is going to be 2 out of 10. Let's write that properly. Okay. So Jatinder will be taking 2 counters at random from the bag, and he will not be replacing it. We want to work out the probability that both these counters are the same color. So let's look at all the different combinations that we can have of the same color, of picking 2 counters. We can have a probability of red and a red, or we can have the probability of a blue and a blue, or we can have the probability of a green and a green. Now, you can put this on a tree diagram, like I said, but it can get quite congested as well. As long as you can picture and imagine what's going on, then you should be fine with just using the fractions. So let's write down our calculations for the probabilities. So for the first one, we want the probability of a red and a red. We want a red, and we want the second counter to be a red. So what's the probability of the first counter being a red? It's going to be 5 out of 10. Times by the second counter being red. Now the second counter, we are only going to have 9 counters first of all, because we've taken a counter out. And because we've taken a red out and we want to know the probability of a second red now, we're going to have 1 less red. So there used to be 5 reds, but we've taken 1 out. There will now be 4 reds. So it's going to be 5 over 10 times by 4 over 9. So that is this. Or is and in probability, so we can put that down. Now I want the probability of a blue and a blue. Maybe you could write these, pause the video, and then write them out, and then you could compare your answers. All right, so blue and a blue is going to be, the first one is going to be 3 out of 10, and the second one is going to be 1 less because we've taken 1 of the blues out, and 1 less from the total overall because we've taken a counter out. So it's going to be 3 over 10 times by 2 over 9. 2 greens we're going to add now. So the first green will be 2 out of 10 times by the second green, which will be 1 out of 9. So here we have our calculations for our probabilities, and now we can just multiply the fractions. So we have here and then we can add all the numerators because all the denominators are the same. So that gives us 28 out of 90, and this is our final answer. And of course we can simplify if you want to simplify. Okay, so on to our final question, another grade 8 question, and very similar to the one that we've just done, where we didn't need to use a probability tree diagram. Perhaps you could do this one at home yourself, so have a look at the question, get it down. There is a part C that I will be adding after I've answered part A and B, so you could do that when you are ready as well. Right, so we have a box of chocolates which contain 12 chocolates. there are 7 milk and 5 white chocolates in there. So let's write down those probabilities because they will be useful for us. So let's write it down here. So the probability of milk is 7 out of the 12 chocolates, and the probability of a white chocolate is 5 out of 12. Hopefully you can see that. I know that sometimes the board has a reflection of the lights, but as I'm saying it, hopefully you can hear that. So the probability of milk is 7 out of 12 and the probability of white is 5 out of 12. Now 2 chocolates are chosen at random without replacement from the box. So you select one and then you select another. Given that the first chocolate is a milk chocolate, what is the probability that the second one is a milk chocolate? So what are we looking for here? We're looking for the probability of milk because that's the one that's been given, and the probability of the second one being milk as well. So the first one's probability of it being milk is going to be 7 out of 12 because that's how many chocolates that are milk out of the 12. Times by the probability of the second one being milk, which is going to be 6 out of one less total, remember? So it's going to be 11. So 6 out of 11. And we will now calculate this. So that will give us 42. And this one, 12 times 11 is 132. And that is our answer. Now, part B, calculate the probability of at least one milk chocolate being chosen. Once again, we can do this question by looking at the different combinations where we have at least one milk chocolate in it, or we can do 1 minus the probability of 2 white chocolates being chosen. So let's show you the combination as well. So we can have the probability of milk and milk. In fact, I won't write it with the intersection sign because it can get confusing. So we can have the probability of a milk and milk, so 2 milk chocolates, or we can have the probability of a milk and white, or we can have the probability of a white and milk. See, all of these combinations, they include at least one milk chocolate. But like I said, the 1 minus the probability of 2 white chocolates is quicker to do. Otherwise, you'll multiply this, multiply this, multiply this, and add them together. So this one will just give our answer quicker. So 1 minus the probability of 2 white chocolates. So what is the probability of 2 white chocolates? Well, the first one being white is going to be 5 out of 12, which we wrote down earlier. The second one being white is going to be 1 less than 5 here, so 4 out of 11. So we can just calculate that. So if we work here now, so 1 minus 5 times 4 is 20, and 12 times 11 is 132. And all we now need to do on a calculator is 1 minus 20 over 132. So let's get our calculator and do that. And that gives us 112 over 132. Now, the third question, which I couldn't fit onto the board earlier, is what is the probability of picking 2 different chocolates? Do you want to have a go on this one yourself and then press play again when you are ready to go through it with me? All right, so let's look at this now then. We want the probability of choosing 2 different chocolates. So what are we looking for? We're looking for the probability of, for example, the first one being milk and the second one being white. Or we are looking for the probability of the first one being a white chocolate and the second one being a milk chocolate. Now, there are no other possibilities because we're only picking 2 chocolates. So it can either be a milk and a white, or it can be a white and a milk. So let's write down these probabilities. So what's the probability of a milk on the first chocolate? It's going to be 7 out of 12. Times by the probability of a white on the second chocolate. Now, the white chocolates haven't been touched yet because the first one was a milk. So the whites will still have its original 5 chocolates, but it's going to be out of 11. So the probability of milk and white is going to be calculated from this. So let's put that in a bracket. Or is a plus. So now for the second one, we want the probability of a white and milk. So probability of a white for the first chocolate is going to be 5 out of 12 times by the probability of milk for the second chocolate. Again, the milk hasn't been touched here because you've had a white on the first one. So the milk will have its original 7, but out of 11 chocolates in total. So now we will calculate those. So 7 times 5 gives us 35 over 132. And that also gives us 35 over 132. And then we just add the numerators, which gives us 70 over 132. And that is your answer for the probability of choosing two different chocolates. Thank you for watching, guys. Hopefully you've enjoyed this lesson and you understand how to apply conditional probability using probability tree diagrams and also without those tree diagrams. Don't forget to press the thumbs up button on the video and please share with your friends and family and anyone who may be doing their GCSEs at the moment. Goodbye for now and see you in the next video.